So let's say I give you two functions. F of x is defined to be 3x minus 4, and g of x is going to be 2x squared minus 1. And then I am asking you to find a series of things here. So when I say f plus g of 0, all that means is you're going to plug a 0 into f, you're going to plug a 0 into g, and you're going to add those two things together. Okay, so if you put a 0 into f, what do you get out? -4. Do I need to show my work on how I got that? If you plug 0 into g, what do we get? So add those together, and our final answer is -5. So B, same idea. What number are we plugging in this time? 4, and then we're going to subtract the two answers. So f of 4, if I put a 4 in here, 3 times 4 minus 4. So we get 12 minus 4 is 8. G of 4. So 2 times 4 squared minus 1. So 4 squared is 16, times 2 is 32, minus 1 is 31. So 8 minus 31, 820. You guys do C and D for me. So for part C, if you put a -2 into function f, you get -10. When you put it into g, -2 squared is 4, times 2 is 8, minus 1 is 7. So you get -70 out. The last one, 9 minus 4 is 5. And you have 18 minus 1 is 17. So you get 5 over 17. Are you guys okay with that? All right. So let's talk about the domains of these things. If you are looking in your book, they have some very long, complex things describing how to find the domain. Basically, when we add subtract, and multiply, we have to find the overlap of the original domains. Division is the same, except we also have to make sure that the denominator is not 0. And I'm going to do an example to kind of illustrate this a little more. But when I ask you to do multiple calculations, the domain is the exact same when you add, subtract, and multiply. And when we divide, it's the same, except we may also have to exclude one more value because the bottom of a fraction can't be 0. So I'm going to give us a couple functions, and we're going to do some calculations and find the domain. The difference is I'm not going to give us a number to plug in. So if I said f of x is the square root of 4x minus 1, and g of x is x over x minus 3. So I want to find f plus g of x and its domain. So the difference is we don't have a number to plug in. So we just literally are going to do f of x plus g of x. So f of x is just the square root of 4x minus 1 plus g of x is x over x minus 3. Do I have any like terms or anything I can combine here? No. So this is my answer. That's what we get when we add those things. Okay, I'm not looking for any fancy algebra. Just combine any like terms that we can. But the second piece I asked for is the domain. So what we have to do, I said to find the overlap of the original domains. So we need to look at each of these original functions. If we have a square root, what do you know about something under a square root? What does it have to be? Positive. So that means 4x minus 1 has to be greater than or equal to 0. If I solve that, I get that x has to be greater than or equal to 1/4. If you have a fraction, what do you know? Bottom cannot be 0. So x minus 3 can't be 0, so that means x cannot be 3. So for this domain, I have to put these two statements together somehow. I'm looking for interval notation. So if it helps, you might even draw yourself a number line. It doesn't have to be real precise. Greater than or equal to 1/4 would start at 1/4 and go forever. Not equal to 3 is everything except 3. So everything smaller than 3, everything bigger than 3. I want the overlap. What is included by both of those? Yes. Since 1/4 is included by both, it gets a bracket. We have to stop at 3. This one did not include 3, so it gets a parenthesis. Union, and then after 3, everything got included. So that is my domain. 1/4 to 3, union 3 to infinity. All right. Is that one okay?
Can I borrow a calculator?
Sure.
Thank you.
You're welcome. Yes.
Why isn't it negative if x goes out?
Okay. So it has to make both of those true. So if I pick something smaller than 1/4, if I plug in a 0, then when I put it in here, I get an imaginary number. So I need it to make this whole statement true. So it can't be anything smaller than 1/4, because if it is, I can't do the square root. And it can't be a 3, because if it is, I divide by 0.
Okay.
Other questions there? Alright. Let's look at the division. So f divided by g. So f is the square root of 4x minus 1. G is x over x minus 3. Do we leave a fraction in a fraction? How do you get it out? Flip and multiply, yeah. So we have to take it times, and we're going to flip this one. Or were you meaning multiply by x minus 3 on top and bottom?
Yeah.
That would work too. So we get an x minus 3 times the square root of 4x minus 1 over x. Okay, it's not pretty. We don't really have to multiply this out. It's not going to help us. This is as far as we can go. So my domain, since I'm involving these same two functions, the domain when I add, subtract, multiply is going to be the same. Division is also the same, except I also have to verify one thing. When I go to my final answer, I know the bottom of this fraction cannot be 0. So x cannot equal 0. Alright, so if I look at what I've already figured out my domain to be, do I have to worry about 0 in here? No, if I'm already 1/4 or bigger, it doesn't include 0, so my domain is the exact same thing this time. Any questions so far? Let's practice evaluating functions if I don't give you an equation. I'm going to give you a couple different representations. So the first one, I have a upside down parabola and an absolute value function here. So if I want f plus g of 1, 1 is my x. Okay, so you're going to your graph. When x is 1, here's where we are. So this is saying f of 1. So when x is 1, the y value of f is 3. G of 1, so when x is 1, the y value of g is 1. And 3 plus 1 is 4. Okay, so just understand that this value that you're putting in is your x, and I'm asking you to do something with their y's. So when I say f minus g of 0, so when x is 0, what's the value of f? 4. What's the value of g? So 4 minus 0 is 4. So f times g of negative 1. So when x is negative 1, the y value of f is 3. The y value of g is 1. Does everybody understand where we're getting these numbers? So I'm giving you x and you have to find the y. So f divided by g of negative 2. So when x is negative 2, the y value of f is, yes?
In the last one, why did you subtract 3 minus 1?
Oh, I don't know. How about multiply? So how about 3? Is that better? Thank you. Alright, so on this one, when x is negative 2, the y value of f is 0, y value of g is 2, and 0 divided by 2 is 0. I want you guys to try to do these with the table. So f plus g of 1, so we're looking when x is 1. F of 1 is 1, g of 1 is 6. Did you guys get 7? F minus g of 0, so that would be negative 1 minus 4, so negative 5. f times g of negative 1. So negative 3 times 2, negative 6. And f divided by g of negative 2. So negative 5 divided by 0, which is undefined. No solution. Can't divide by 0. All right. Can we handle those? There's 2 things that I have left that I want to cover today, and then I'm going to give you guys some time to work on your homework. So the first one is still just dealing with function notation. But for this function, I'm going to ask you to find a couple things. Okay, so it's a 3-part question. Here's our function. Part 1. I want you to find f of x plus h. What does that mean? If I said find f of 3, what would you do? Put 3 in for x. So if I say find f of x plus h, that means you replace x with x plus h. Okay, so if we just distribute, we get 2x plus 2h minus 3.
That's it?
That's it for f of x plus h. Second thing I want, f of x plus h minus f of x. So f of x plus h, we just worked out, was 2x plus 2h minus 3. Minus, what is f of x? 2x minus 3. What would you do there? Distribute your negative and combine like terms. Positive 2x and negative 2x cancel. Positive 3 and negative 3 cancel. And so all we get is 2h. Third step, I'm asking for f of x plus h minus f of x divided by h. F of x plus h minus f of x, that's what we just found. And we got 2h. Then I want you to divide that by h, and you get 2. And so that is my final answer. This is something, it's called the difference quotient. It's used a lot in calculus. College algebra, it's just practicing with our function notation. So I wouldn't expect you, I won't just say like find the difference quotient and expect you to know what that means, but I would ask a 3-part question like this, just testing if you can evaluate that. Should we do another one? Or do you guys think one more? All right, how about part 1, f of x plus h. So what do I do? Right, I have to distribute negative 6. So we get 5 minus 6x minus 6h. Second part, I would ask you for f of x plus h minus f of x. So f of x plus h, we just worked out, minus f of x was 5 minus 6x. So we distribute negative. Positive 5 and negative 5 cancel. Negative 6x, positive 6x cancel. And we get negative 6h. Third part, f of x plus h minus f of x, which we just found to be negative 6h, divided by h, and we get negative 6. Alright, is that one okay? Very last thing I'm doing today, do you guys remember compositions at all from Mrs. Keller's class? Okay, let me put, we're just going to probably do these two today, and we'll pick up with these tomorrow. Okay, so last two. So that composition, it's got that little circle there, or it might be written as f of g of 1. So you start on the inside. So the first thing I have to do is g of 1. So what do you do for that? Yeah, you plug a 1 into function g, so 4 times 1 is 4. So you replace that g of 1 with a 4. So now I have to do f of 4, so I go to f and plug in a 4. So a composition is just a way of telling you to do a series of calculations. You start on the inside and you work your way out. So I get 16 times 8 is 32, or times 2 is 32, minus 3, I get 29. Does order matter with compositions?
Yes.
Yes. This one is different because what do you have to do first here? Right, start with f of 1. So if you put a 1 into f, what do you get out? Negative 1. So I'm going to plug a negative 1 into g. And we get a negative 4 for our answer. So order does matter. Work inside out on those. Is that okay with everyone? So we have about 15 minutes and I have a handout for you. I'm giving you time to work now so you can ask questions if you get stuck in